Assalamualaikum and hi, my name is Nur Sahira and my partner's name is Syafiqah. Today we are going to present about characterization of PV module which is from experiment 3. And then now I start with the objective of this experiment. Okay, as we all know that this experiment consists of 4 objectives. Okay, which is first to determine the IV curve characteristic of PV module, and then to determine the PV curve characteristic of PV module, and then the third one is to determine the fill factor of the PV modules, and the last one is to determine the
conversion efficiency.
Okay, there are some equipment that we use in this experiment either for safety or to collect the data. Okay, for example, we need the hard hat, glove, goggles for safety, and for the data collection, we need the climate digital multimeter, solarimeter, temperature measurement, PV module data sheet, connection cables, and also switch ports. Okay, next, we move to the procedure of the experiment. Okay, first of all, before we set up the circuit, we need to record the module specification. Okay, the module specification is located at the behind of the module. Okay, from that, we can see and know every detail and specific about the module as shown in the figure attached. Okay, after that, we need to set up the circuit action in the figure on the right slide. Okay, set up all the equipment involved for taking the data such as climate, switchboard, solarimeter, digital multimeter, connection cables, and the last one is variable resistor, which is stand for VR. Okay, the important things that we need to remember is make sure that we already connect all the cables and equipment in the right way and right connection. For example, positive, positive, negative, negative. It is to avoid the parallel error while taking the data. So we need to check the connection of the equipment and cable twice. Okay, then before taking any measurement, we need to set the mode on digital multimeter for measuring voltage, and then reset the meter and variable resistor equal to 0 for the short circuit, and then use the meter to measure the value of IAC. Then we need to repeat all the steps before to get about 20 set of data for current and voltage. And then for the last reading, set up the variable resistor as maximum or infinity. This is for the open circuit. And measure the VOC and record the data. Okay, for the last one, measure and record the following information at the end of the experiment.
Okay, next for the result and data. The table 3.1 show the datasheet of PV module utilized in the experiment as well as the information at the side. In the datasheet, we can see the information about the PMP, VMP, VOC and also ISC. The value of IMP was calculated using this information. And we also know that the experiment was placed in evening and at the Makmal Lapangan FSG. And then for the table 3.2, it shows the data of the beginning and at the end of the experiment. Next, for the table 3.3, it shows the experimental data that was recorded during the experiment. The solar irradiance, voltage, current and power was recorded in the experiment. The formula P equals to IV was used to calculate the value of the power. Okay, this is the graph that we obtained from the measurement of the experiment. And next, this is the sample calculation of the experiment that shown the calculation of fill factor and efficiency. Okay, for this experiment, the electrical characterizations of PV module was studied. To characterize a PV module, the strength of cells was used because a PV module is characterized based on the current voltage performance of a string of cells in the module. Furthermore, to characterize a PV module, both IV curve, which represent the relationship between the current and voltage, and the power curve, which represent the relationship between the power and current, will apply. And then the both IV curve and power curve are valid at a particular irradiance and also a temperature only. Okay, for the maximum power of the PV module, it was determined by the IV curve. And then for the maximum power current, maximum power voltage, open circuit voltage, short circuit current are necessary to monitor and alter in order to keep the PV system in a good operating order. Then, in this experiment, the IV curve was created by adjusting the resistance to produce a given voltage and current data. The module outputs parameters such as current and voltage were specified by the raw data, while the module power was calculated by using the formula given, that was P equal to IV. Over the course of the trial, the solar irradiance will increase from 250 watt per meter to 257 per meter. And then, as a result, the current should rise, while the voltage should rise slightly as well. And then, the ambient temperature will decline from 35 Celsius to 34 Celsius, but the PV module temperature was increased from 43.2 Celsius to 43.6 Celsius. As just an outcome, the current will slightly rise while the voltage will decrease proportionally. And then the open circuit voltage will decrease and the power output will increase. The solar irradiance was related to the power output, so as a result, the solar irradiance will slightly rise. The temperature and sun irradiance were found to be a parameter that could influence the performance of PV module. Based on the graph of IV curve and PV curve, we can compute the fill factor and also the efficiency based on plotted graph. The efficiency was determined by using the fill factor that was obtained in the experiment. As shown in the graph, the fill factor is a measurement of IV curve squareness. The following formula of the fill factor and efficiency was shown in the slide. From that, the value fill factor calculated is to be 0.687 and the efficiency is 15.99%. Moreover, it can be seen that the theoretical value from the data sheet is very slightly from the value of the experiment. This is due to the external factors such as temperature and the amount of solar irradiance encountered the experiment using the value obtained under actual operating control. A PMP value of 78.8 watts was obtained at irradiance of 0.15 watt per meter and IMP value of 2.5 ampere was obtained from the power curve. As a voltage increased, it was observed from the graph that the current will decrease. Okay, while carrying out this experiment, there are many preparation steps that we need to be considered, such as when take the measurement of time, radiance, voltage, currents, and also module temperature. All of these need to measure at the same time. Other than that, all the equipment need to be properly set up and connected, because incorrect connection can lead to the inaccurate reading. Finally, this experiment involves a large amount of energy, so we should wear a personal protection equipment. Okay, last but not least, we can conclude that in this experiment, the electrical characteristic of PV module was successfully investigated. And then both IV curve and PV curve characteristic of PV module were determined by plotting the graph from the measurement obtained. So, in addition, the fill factor and efficiency were determined to be 0.687 and 15.99% respectively by calculating from the obtained value. Thus, the objective of the experiment were realized and accomplished. And finally, the experiment should be carried out with attention to avoid the error. So I think that's all from us about the experiment 3. Thank you.